Okay, moving right along. With determining the subnet number of a given IP address, we're going to perform something that we call a Boolean AND operation. Now, I want to tell you, if you thought that people's reactions to binary were bad, when you're talking about binary and then you throw in, we're going to do a Boolean, I have seen some cattywampus explanations of this, man. I'm telling you. Whether it's from Cisco or a non-Cisco source, I've seen some convoluted stuff. And this is actually even simpler. You already know how to do the binary extractions, right? Turning a decimal into a binary. Let us not complicate the Boolean AND. All we're going to do is convert the numbers that we are comparing to binary. And this is why a fundamental binary conversion skill is vital. And all a Boolean AND is a bit-by-bit comparison of the two binary numbers. We're comparing the address we're given and its subnet mask. Now, as you're comparing bit by bit, if both bits are 1, then the result is 1. If there is any other combo, the result is 0. So again, we're just laying out two binary numbers side by side, much like you see above there, where the network mask is, subnet mask is. You'll just see two strings of numbers side by side. You're comparing those two bits. If they are both 1, the result is 1. Anything else is a 0 in the generation of the Boolean AND result. That's it. Let us not overcomplicate this. You just write it out and compare. So we're going to walk through an example, but if you see a 1 and a 1, it's just a 1. Anything else is 0. I'm positive we can handle this. Now I want you to do this. The IP that we will use in this example is 178.56.21.9. Subnet mask of 24. You should be able to convert that to binary. No problem at all at this point. If you're watching this in video form, pause it and do the conversion, then continue. I'm going to write them out myself also, but go ahead and pause this, do the binary conversion right now. So this is just a reflection of the first 3 numbers of the original IP address. But that's why you're under that impression. Just don't let yourself be fooled. The subnet number of a given IP address is not necessarily always the first 3 numbers of that IP address. It just looks that way because if your subnet mask is /24, then you are going to get the first 3 numbers. But if you calculate it in reality, this need not be all 1s, so it will not be the 3rd number of the IP address. Just be aware of that. Okay. So, that's our result. Easily. These are what I like to call the 2 or 3 in 1 style of question, because this may be the one question where they try slash notation on you, for instance. They'll check a couple of concepts all at the same time. They'll give you the problem with slash notation and then give you the answer in like decimal dot notation, so just be ready for it. Now, we'll do one that's not so easy, one that requires the actual calculation for you to accurately and properly come up with the subnet number. The next one we'll try is this one, and do the same thing. Do it right along with me. In fact, stop and do it ahead of me and just check your work. Say you're given this and somebody walks up to you and says, we've got a connectivity problem. We need the subnet. Can you help me out? This is the IP and the subnet mask. Now what? What do? You've got to write it out. Just do the numbers, just like you've been doing. Here, I'll type it out, you pause, and you do it ahead of me. So, those are the numbers laid out, and now I'm going to lay them closer for the comparison to do the Boolean AND. All the first three numbers are the same, but here in the fourth octet, as you see, the subnet mask continued on. So here's the Boolean AND. It is 0, 1, 0, 0, 0, 0, 0, 0. Okay, so this is your Boolean AND. It's the result of the simple bit-by-bit comparison. And we now have our network with a mask of 27. So remember, where are our host bits? It's where the zeros in the network match up to the zeros in the subnet. Now if the subnet's here, and those are the zeros, and this is the network that we just calculated, it's where the zeros of the network match up to the zeros in the subnet. So how many host bits is that? That's 5 host bits. Now I know this is the first time that you're seeing that last octet not be a 0, and you'll have to get used to that. You're actually going to see this a lot, and that is the entire idea. You've got to be able to figure out these subnets for clients. So the final result of this subnet, if you were to convert this final octet into a decimal number, it's easy to do. You've got only one 1 in one place, and if you know your places, that's 64. So the final number in the octet is 64. That is the network number. So the result is this subnet, 200.150.150.64/27, or if it's in dotted decimal, it's that. Alright? It's just a simple Boolean AND. And the first number in the range is 200.154.150.64. This is called the network number. So what about the last number in the range? Well, that would be when all the host bits are set to 1. In other words, the final number will be, now be careful with this, because remember, we're dealing with 5 host bits. It's these last 5 numbers that are all 1 for the last number in the range. And that would make that number 0, 1, 0, that's 3, 4, 5, 6, 7, 8. The final 5 are 1. And that number equals what? I would say stop and do the conversion. But I'm going to tell you that it's 95. And you've got to be careful, because a lot of people will tell me 31. And that's the result of these. And people forget that they are adding this because you are doing the entire octet. This is the final address in the range, and this is known as, actually I'll put it up here, the broadcast address. So, what are the valid IPs? Well, you exclude the endpoints. Like the formula says, it's -2. You subtract the network number and the broadcast address. And that leaves us with a range of not 64. The first valid address is 65. And it's not 95. The final one in the address range is 94. And that is why we subtract 2 from the valid hosts. The endpoints are unusable. So say we put the first 3 on hosts, 65, 66, and 67. Then we might be told, okay, go and put the last address on router interface Ethernet 0. And that would be 94, because 95 is the broadcast address. And this, you see folks, this is not just practice for the exam. This is real world stuff. You've got to be able to do this. If you are just given an address, you've got to be able to do this. It takes practice, and that's all. You can make up your own questions, but you've got to be able to say, okay, I'm a network admin. I know this is the first and last address. and this is the range, and this is what I can actually use. Like I said in the beginning, this all actually comes back to binary to decimal and decimal to binary. It's all just ones and zeros, guys. The more you do this, the more comfortable you'll get with it. So that's why we're beginning with it. Got to introduce you to it, let it digest, let you get good at it. No one's going to ask you what 37 is in binary. They're not just going to walk up in the middle of lunch and say, hey, convert this to binary. But someone could walk up to you as a network admin and say, we've got this range of addresses here, 200.154.150.64/27. What do we do now? What is the first valid address? The last? What's the range? It just comes back to binary. And speaking of real world, I'm going to get to a situation now. Let's call this, we'll call this section here, meeting the stated design requirements. And this will be in the exam, but it is also real world. They'll walk up to you and they'll say, hey James, or hey Cynthia, here's our network number and this is what we're going to do. Or we're going to need this many subnets, and we don't want the subnets to have more than this many hosts, or we want them to have at least this many hosts maybe. What should we do? And you will have to fulfill the stated design requirements, at the very least for the exam, and very likely in the real world. Now here I may put myself, I may give you which of the following subnet masks should we use and or give you info. But in the real world, no one's going to give you multiple choice. You've got to figure it out on your own. And we might as well take a moment here just to briefly remind you too of the two equations that we used in our analysis, and we will use this in figuring this stuff out. The number of subnets is 2 to the nth power, where n equals subnet bits, and in the case of the number of hosts on a subnet, that equals 2 to the nth power minus 2, where n is the number of host bits. When you're calculating valid subnets, you're using subnet bits, and when you're calculating valid hosts on that subnet, you're using the host bits. So let's write this down. We're going to work on a problem here, and we're going to use a Class B network like this. And we will need at least 150 subnets that have no more than 200 hosts apiece. Which of the following subnet masks should you use? And I'll bet in the exam they won't even mention that it's Class B. You'll have to just recognize it. Because now we are actually doing the subnetting here in this case. And see, with the other questions we've looked at, they were all valid questions to prep for the exam or for real world, but a lot of the time you're going to be walking into the client site, or you're going to take a new job, and maybe something goofy has been going on this network for a while and nobody's been able to troubleshoot it yet. Maybe it's a smaller business and it's growing. They've had one good network admin all this time, but now they actually need another network admin, and they're choosing you for your Cisco skills because they've got a couple of routers and switches. Maybe they've got an office in another part of the country, another state. You've got to figure it out. Something like this comes up. What are you going to do? Once you walk into these situations and go over it a few times, you'll know exactly what to do. So let's just take a look at this one right now this way.